Welcome to the fourth part of mechanical properties of solids. In the third part, you have learned about the stress-strain relationship curve. Now we will study some conclusions drawn from that particular stress-strain relationship curve. And after that, bulk modulus of elasticity. Conclusion. An object is brittle if D and E are very close. This means fracture point is near to the tensile strength. For example, glass, which is brittle, and if it is dropped, it will easily break into pieces. An object is ductile if D and E are very far apart from each other. This means the fracture point is far away from the tensile stress. For example, metals, gold, silver, etc. And the property of being drawn into thin wires or sheets is known as ductility of the material. The materials which can be elastically stretched to large value of strains are called elastomers. For example, rubber can be stretched to several times of its original length, but still it can regain its original length when the applied force is removed. There is no well-defined plastic region. Rubber just breaks when pulled beyond a certain limit. Its Young's modulus is very small, about 3 into 10 is to power 5 Newton per meter square at low strains. As shown, elastic region in such cases is very large, but the material doesn't obey Hooke's law. In our body, the elastic tissue of aorta, the large blood vessel carrying blood from the heart, is an elastomer for which the stress-strain curve is shown in the adjacent graph. Bulk modulus of elasticity. Within the elastic limit, the ratio of normal stress to the volumetric strain is called bulk modulus of elasticity. Mathematically, it is normal stress divided by volumetric strain. And you know that normal stress is force upon area and volumetric strain is delta V by V. So, you will get F by A into V divided by delta V. That means F by A, you can put it as the normal pressure. So, B is equals to, or K is equals to minus P divided by delta V by V, or you can say minus P into V divided by delta V. Negative sign shows that the volume decreases with the increase in stress. The SI unit of bulk modulus is Newton per meter squared or Pascal, and its CGS unit is dyne per centimeter squared, and the dimensional formula is ml minus 1 T minus 2. And in compressibility, reciprocal of the bulk modulus of a material is called its compressibility. Mathematically, compressibility is 1 by B and its SI unit will be then n-1 meter square. And the dimensional formula will be m-1 LT2. Let's solve a numerical based upon this concept. It's your NCERT example 9.5. Average depth of Indian Ocean is about 3000 meter. You have to find out the fractional compression. That means delta V by V of water at the bottom of the ocean, and it is given to you bulk modulus of water is 2.2 into 10 raised to power 9. And you have to take the acceleration due to gravity as 10 meter per second square. The pressure exerted by a 3000 meter column of water on the bottom layer will be H rho g. Put the value and you will get 3 into 10 raised to power 7 Newton per meter square for this one. The fractional compression delta V by V will be then stress divided by B, the bulk modulus. And by putting the value, you will get 1.36 into 10 raised to power minus 2 or 1.36%.